Let's start on today's questions and answers. These are questions and answers regarding the calculation of concentration of solutions. This is starting on question 36. Question number A is asking what is the molarity when 0.75 mol dissolved in 2.5 liter of solution. For this kind of question, we need to calculate the molarity. And the formula for the molarity, molarity is equal to the number of moles dividing with the volume of solution in liters. So we need to change the volume of solution in liters in case the volume was not given in liters. But for this question, it was given in liters. We will take the number of moles, 0.75 moles, dividing with 2.5 liters that was given, then we will obtain 0.3 molar as the concentration of solution in molarity. And number B is asking to calculate the molarity of 25 gram potassium bromide dissolved in 750 milliliters of water. So the same, we are going to use the same formula where molarity is equal to the moles dividing with the volume of solution in liter. The volume of solution was given in milliliter, we will change it to liter. Then we don't have the number of moles, so we need to first calculate the number of moles. We have 25 grams of potassium bromide. We immediately change the mass to moles by dividing with the molar mass. The molar mass of potassium bromide is 119 grams per mole. Taking 25 grams dividing with 119 grams per mole, we obtain 0.21 moles as the moles of potassium bromide. Then calculating the molarity by taking the number of moles dividing with the volume in liter, 0.75 liter. That is the conversion of volume from 750 milliliter of water converting to a liter, we get 0.75 liter. Then the molarity will take 0.21 as the number of moles dividing with 0.75 liter. Then we will obtain 0.28 molar. So as the molarity of our solution. Going to number C. Number C is asking how many grams of potassium chloride are needed to prepare 125 milliliter of 0.72 molar potassium chloride solution. So this question we are having the concentration. We have also the volume of the solution, and we need to determine the mass of the of KCl. For this one, we need to check on the formula and rearrange the terms so that you can find how to calculate the mass. We know that the molarity is equal to the moles of solid dividing with volume of solution in liter. Replacing the formula for the moles, we know that moles is equal to the mass dividing with the molar mass. So by replacing the value of moles equal to mass dividing with molar mass, we obtain the molarity is equal to the mass dividing with molar mass times the volume of solution in liter. If we simplify the formula, we are getting the molarity is equal to the mass dividing with molar mass times the volume. Then from this formula, you can rearrange and find the formula for the mass. We will have a mass equal to the molarity times the molar mass times the volume. So we have the molarity which is 0.72. We have also the molar mass. The molar mass of KCl is 74.75 grams per mole. We have also the volume 125 milliliter, but we need to change it to liter. Then we calculate the mass. We find the mass equal to 6.71 gram. Mass of KCl is equal to 6.71 gram. So that was number C. Let's move to number D. Number D is asking what is the volume of formula solution made using 100 grams of lithium bromide. Here also we need to arrange the terms. We have 100 grams of lithium bromide, and we have also 4 molar solution, and we need the volume. according to the formula, the molarity equal to the mass dividing molar mass times the volume. So from this formula, you can rearrange the terms and we find the formula for volume, which is equal to the mass dividing the molarity times the molar mass. Then we can replace the values in that formula. The molar mass of lithium bromide is 86.84 gram per mole. Calculating the volume, we take 100 gram dividing 4 times 86.84 gram per mole. Then we will immediately obtain 0.29 liter as volume of solution that was asked. Let's move to another question, which is number E. Number E is telling us that the solution is prepared by mixing 1 gram of ethanol with 100 gram of water to give a final volume of 101 milliliter. And it is asking to calculate the molarity, calculate the mass percent, calculate the mole fraction, calculate the molarity of ethanol in this solution. We can first calculate the molarity. We know the molarity is equal to number of moles of solid dividing with volume of solution in liter. So the solid that we have in this question is 1 gram of ethanol, and the solvent that we have is 100 gram of water, but you have also the final volume, which is the volume of solution. You have it, which is 101 milliliter. This one you need to change to liter so that you can get the volume in liter. Then we need to calculate the number of moles. The number of moles of ethanol, you have 1 gram of ethanol. We know the number of moles is equal to mass dividing with molar mass. The molar mass of ethanol is 46 gram per mole. For us to calculate the moles, we take 1 gram dividing with molar mass, and then we obtain 0.0217 moles. Then we calculate the molarity by taking 0.0217 mole dividing with 0.101 liter. Then we obtain 0.215 molar. The second point, they were asking a mass percentage. That's what we need to calculate, the mass percentage of the solid ethanol as compared to the solution. Mass percentage is equal to the mass of ethanol dividing with the mass of solution times 100. So the mass of ethanol, we have it, which is equal to 1 gram. Mass of solution, you need to add the two mass. We need to add the mass of the solid plus mass of the solvent. Mass of the solvent is the mass of water, which is 100 gram, plus 1 gram, which is the mass of ethanol as a solid. Then you obtain the mass solution as 101 gram. We calculate the mass percentage by taking mass of ethanol dividing with mass of solution times 100. You obtain the mass percentage, which is equal to 0.99%. We need also to determine to calculate the mole fraction. Mole fraction is equal to the moles of solid dividing with the total moles. In this case, we have moles of ethanol dividing with the total moles. We have calculated the moles of ethanol. What we need is to calculate the total moles. For total moles, we need to take the moles of ethanol plus moles of water. Then we obtain the total moles. For calculating the moles of water, we need to take 100 gram, which is the mass of water, dividing with 18 gram per mole, which is the molar mass of water, and you obtain 5.56 moles. The total moles of solution, then we take 5.56 plus 0.0217 mole, which is the mole of a solid ethanol. Then you obtain 5.5817 moles. Then you calculate the mole fraction by taking moles of ethanol, 0.0217, dividing with 5.5817 as the total moles. Then you obtain 0.00389 as a mole fraction for ethanol. Another sub question for this question was asking to calculate the molarity, and which is the mole of solid dividing with mass of solvent in kilogram. So here we don't divide the mass of solution or the volume of solution. For this kind of molarity, we divide with mass of the solvent only in kilogram, which means the solvent that we have here is water. We need to divide with the mass of water in kilogram. So we have 100 gram of water, then we will convert it to kilogram, and we will obtain 0.1 kilogram. Then the moles of ethanol, we have it, the mole of solid, which is 0.0217 mole. Then we divide for 0.1 kilogram as the mass of the solvent, and we will obtain 0.217 molarity. The difference between the two moralities is that this morality that you have calculated using the mass of solvent in kilogram, of course we are using the mass of solvent and we are not using the volume of the solvent. This one does not depend on the temperature and the pressure. Remember, if you have the volume change as a function of temperature and the pressure. If you are changing the temperature, the volume is going to increase, and if you are increasing the pressure, the volume is going to decrease. But this molarity that we are calculating by using mass of the solvent is not dependent on the temperature and the pressure. Number F, we have electrolyte in automobile. Read storage batteries is 3.75 molar sulfuric acid. So you have the concentrated of sulfuric acid solution, and you have the density, of course, is the density of solution, which is equal 1.23 gram per milliliter. Then they are asking to calculate the mass percent. They are asking to calculate the molarity. They are asking to calculate the normality of the sulfuric acid solution. We need to calculate the mass percent. Mass percent, remember we have used the formula for mass of solid dividing with the total mass times 100. Do we have the mass of solid? So we don't have it because we are having sulfuric acid. We have only the concentration in molarity, but from this concentration in molarity we can determine the mass of the solid or the mass of sulfuric acid. Then the total mass we can find it from the mass of solution. Because we are having the density, from the density we can determine the mass. Let's see, we are having 3.75 mole per liter, so which means because we have a mole per liter, the volume of solution is 1 liter, so which is equal to 1000 milliliter. If we are converting 1 liter to milliliter, we get 1000 milliliter. Then we can use the formula to calculate the mass of solid. Remember, the mass of solid is equal to molarity times the molar mass times the volume. So we have demonstrated and this formula from the formula of molarity. So then we get the mass of solid as equal to 368 gram. So we have 3.75 times 98.1. This 98.1 is the molar mass of sulfuric acid, then times the volume in liter, which is 1 liter. Then we know that the density is equal to mass over the volume. Then from the density we can determine the mass of the solution. You know, the mass is equal to density times the volume. Then the mass of the solution is equal to the density, which is equal 1.23 gram per milliliter. Then we multiply with the volume in milliliter also, so that you can get the same unit. We multiply for 1000 milliliter. Then we get 1230 gram as a mass of solution. From the mass of solution, then you can determine the mass percentage by taking mass of solid dividing with the total mass, which is the mass of solution, times 100. Then we will get 29.9%. We know that the molarity is equal to the mole of sulfuric acid dividing mass of solvent in kilogram. Mole of sulfuric acid dividing mass of solvent in kilogram, and you have the mass of solution and you have the mass of solid. So then you can determine the mass of the solvent, which will be equal to the total mass, which is the mass of solution, minus the mass of solid. Then we will get 1230 gram minus 368 gram. Then we will obtain 862 gram, which is equal to 0.862 kilogram as the mass of the solvent. Then we have the mole of sulfuric acid. Then we can determine the molarity by taking mole of sulfuric acid 3.75 mole dividing with 0.862 kilogram as the mass of the solvent, and we will obtain 4.35 molarity. We are going also to calculate the normality. We are asked to calculate also the normality, and normality, normally the way you calculate the normality, you take the number of gram equivalent of solid dividing with the volume of solution in liter. We take the number of gram equivalent of solid dividing with volume of solution in liter. Let's see now what is the number of gram equivalent of solid. This number of gram equivalent of solid is equal to the mass dividing with equivalent weight. So you take the mass that was given, you divide it with equivalent weight to get the number of gram equivalent of solid. Now, what is equivalent weight? So equivalent weight, if we are now dividing the formula, if we are replacing this formula, the number of equivalent of solid, into the formula for normality, we will see that the normality is equal to the mass dividing with equivalent weight times the volume of solution in liter. So we have replaced the number of gram equivalent of solid per mass dividing with equivalent weight. Now let's see what is equivalent weight. Because in the formula, what we don't know now is the equivalent weight. Equivalent weight is equal to the molar mass dividing with equivalent per mole. So when you are the only difference between the molarity and normality is that for molarity we are calculating the number of moles by taking the mass dividing with the molar mass, but for the normality, we calculate what we call the equivalent weight. We don't use the molar mass as it is. We use the molar mass which is divided by the equivalent per mole. We take the molar mass, we divide with the equivalent per mole for the normality. So what we don't know is the equivalent per mole. What is the equivalent per mole then? That's what we will see later. So by replacing now the formula that we have seen, we can see that the normality is equal to the mass dividing with the molar mass times the volume of solution in liter dividing with equivalent per mole. So now if you can check, when you have the mass dividing with the molar, we can then multiply the equivalent per mole in the numerator. Then we get the mass times the equivalent per mole dividing with molar mass times the volume of solution in liter. If you can check in that formula, we are having mass dividing with molar mass times the volume of solution in liter, so which is equal to molarity. So if you can see in the formula, you will see the mass dividing with molar mass times the volume of solution in liter, which is equal to molarity. Then we can say that normality is equal to the molarity times the equivalent per mole. So the term equivalent per mole is coming, and this equivalent per mole will determine it per depending on the reaction type and it depending on the balanced chemical reaction. So it's up to you to determine the equivalent per mole. What is the equivalent per mole? So in calculating the normality, you should be having the equivalent per mole. It is an integer, a constant number which is higher or is equal to 1. So if it is equal to 1, if the equivalent per mole is equal to 1, it means that the normality is equal to molarity. Let's see how this value change. For acid, it is the number of moles of proton ion released by an acid. When you have an acid, then you check the dissociation of the acid. This equivalent per mole is the number of proton released. And for base is the number of mole of hydroxide which is released by a base. And for the salt, it is the total positive valence of metal atoms. You check the valence of total metal atoms there. That will be your equivalent per mole for salt. For oxidation and reduction, it is the number of electrons. So let's see a different example concerning this equivalent per mole. For example, if you have the hydrochloric acid, the dissociation will give 1 proton plus 1 chloride. So this means that the equivalent per mole will be equal to 1 because only 1 hydrogen is dissociated. For sulfuric acid, it will be 2 because 2 hydrogen is dissociated. For phosphoric acid, it will be 3. For acetic acid, it will be 1. As you can see, only 1 proton is the one which will be liberated. Then for the normality, because normality is equal to 1 times molarity, then for sulfuric acid it will be 2 times molarity. For phosphoric acid it will be 3 times molarity, and then for acetic acid it will be 1 times the molarity. For sodium hydroxide it will be equal to 1 because of 1 hydroxide. For calcium hydroxide the equivalent per mole it will be 2 because of 2 hydroxide. And again, if we are now calculating the normality, for sodium hydroxide we take 1 times the molarity, and for calcium hydroxide we say that normality is equal to 2 times the molarity. For other reaction, like for example aluminium, for the redox reaction, we will count for the electron which are either in oxidation or in reduction reaction. So then we move to our question. Since each sulfuric acid molecule will dissociate and give 2 protons, as we have seen in the table above, it means sulfuric acid has 2 equivalent per mole. So to calculate the normality, we will take 3.75 as a molarity times these 2 equivalent per mole of sulfuric acid, and we will get 7.5 normal. Then let's go to number G. Calculate the normality of 0.74 gram of calcium hydroxide in 10 milliliter of solution. Here we have a mass. We have the mass. We need to calculate the molarity, but we need to first calculate the number of moles by taking the mass dividing with the molar mass. After getting the number of moles, we calculate the molarity by taking the moles dividing with the volume of solution. The solution is having 10 milliliter. Then we convert to liter by dividing with 1,000, so we get 0.01 liter. Then the molarity will be equal to 0.01 mole dividing with 0.01 liter. We will get 1 molar as the molarity. Then as the normality, so we will check the normality by taking the molarity times the equivalent per mole. But we have calcium hydroxide which will liberate 2 moles of hydroxide. Then we will have 2 equivalent per mole. So then we calculate the normality by taking the molarity, which is 1 mole per liter, times 2 equivalent per mole, and then we will get 2 normal. Let's move to number H. Number H is asking to calculate the normality of 13.4 gram of sodium oxalate in 100 ml solution. So this is the normality of the salt. The same as we will do by calculating the molarity. We start by calculating the number of moles. After calculating the number of moles of sodium oxalate, then we will calculate the molarity by dividing with the volume. The volume is 100 milliliter. We will convert to liter, which will be equal to 0.1 liter. Then we will get 0.1 dividing with 0.1, so we get 1 molar as a molarity. Then after getting the molarity, we will calculate then the normality after determining the equivalent per mole. For this sodium oxalate, we are going to check the dissociation, and we see that is a salt, and for the salt we will count the total positive valence of sodium ion which is present. If it is any other metal, we are going to take the total positive valence of a metal, but here for sodium oxalate we are having sodium, and we will count the total positive valence of sodium ion which are present. We have sodium plus, but check we are having 2 sodium, 2 times 1, because sodium has 1 as a valence. In that case we are having 2, so which means we have equivalent per mole for this sodium oxalate of 2. So then we calculate the normality by taking molarity times equivalent per mole. We take 1 times 2, then we get 2 normal. Let's move to number I. The stock solution available in your reagent chemical store has the following indication. It is indicated as dangerous, corrosive, toxic, harmful, and the density was given as 1.84 gram per centimeter cube. You have also the percentage of this chemical, which is 98%. You have also molecular weight. You have 98 grams per mole, and of course it is indicated as a sulfuric acid. So it is a sulfuric acid chemical. Then they are asking to calculate its molarity and its normality. And then they are asking explain how will you prepare 2 molar sulfuric acid solution from this stock solution, having in your disposition 100 milliliter flask. For this kind of question, of course, we cannot calculate the normality without having the molarity. So we need to have the molarity, then we multiply with equivalent per mole to get the normality. For sulfuric acid, we know the equivalent per mole is known is 2, because it will exchange and two proton will be liberated during the dissociation. Then we have the molecular weight, we have the density, and you have the molar mass. Then we have also the percentage, molecular weight, you have the percentage, you have the density, and then they are asking to prepare 2 molar sulfuric acid solution. So if they are asking to calculate 2 molar sulfuric acid solution, so we need to first know what is the concentration in molarity of this sulfuric acid solution. So that's what we need to know first. Let's check whether we can calculate the molarity from the information that we are having on the bottle. So we have a concentration which is equal to 98%, the concentration in percentage. So this means that you have 98 grams of sulfuric acid as a solid per 100 grams of solution. That's what the percentage means. It means you have 98 grams of sulfuric acid per 100 grams of solution. So then for this concentration, which in the percent to give the molarity, we should be able to convert the denominator to liter and the numerator to moles. So which means we need to change 98 grams to moles, and we change also 100 grams to liters. Let's see how we can do it. We know that the moles is equal mass dividing with the molar mass. So which means for the numerator, we can take the mass, which is 98 grams, dividing with the molar mass of sulfuric acid. Then we get the number of moles. But below we have 100 grams of solution. How can we convert to liters? How can we convert to volume? In that case, we are going to use the density, because the density was given as 1.84 grams per centimeter cube. We know the density equal to mass dividing with the volume. Then the volume will be equal to mass dividing with the density. Then changing the denominator to liters, we take 100 grams dividing with the density, which was given in gram per centimeter cube. Let's do it. So by doing so, we are having concentration equal to 98 grams, dividing the molar mass in gram per mole. So this is the molar mass of sulfuric acid, of course. Then by changing the denominator, we are taking 100 grams, we dividing with the density in gram per centimeter cube. 100 grams dividing with the density. So the density is gram per centimeter cube. Then so the concentration. So this 98 grams is the percentage. So the molar mass stay there. We take 100 and divide it with the density. So then we can continue. We have 98 grams, the molar mass in gram per mole, 100 grams, dividing with the density in gram per centimeter cube. So we can cancel the unit which are the same. So then we obtain the 98 dividing with the molar mass, because the gram above there they will cancel. Then we retain, we remain with 100 per density centimeter cube. So we are remaining with the moles the above, and we are remaining with centimeter cube. So we don't have more per liter. So we need to change this centimeter cube to liter. To change the centimeter cube to liter, we will divide by 1,000. By dividing 1,000, that's what we are going to see. So we are taking 98, dividing with the molar mass, dividing with 100, dividing with the density, times this centimeter cube, dividing with 1,000 centimeter cube per decimeter cube, 1,000 centimeter cube per decimeter cube. Then the unit they are going to cancel. We cancel centimeter cube. So we are remaining with mole per decimeter or mole per liter, which is molarity. Of course, if you are canceling 100 and 1,000, we remain with 10. So that is the 10 that you see in the formula. Then we get concentration equal to 98, dividing with the molar mass, dividing with the 1 over density times 10. Then by rearranging, you have the formula where concentration in molarity will be equal to 98 times the density times 10. So recall that this 98 is the percentage. So we can get then the formula of calculating the concentration in molarity. If the solution is having the density and the percentage, we can take the percentage times the density times 10 dividing with the molar mass. So we use this formula here then in the other calculation. Concentration is equal to 98 times 1.84 times 10 dividing with 98. Then we get 18.4 molar. After getting the concentration in molarity, we calculate the normality by taking the molarity times the equivalent per mole. Equivalent per mole for sulfuric acid is 2. Then we get 36.8 normal. From this solution, which is 18.4 molar, we will calculate how much we need to pick, how many milliliter we need to pick from this stock solution to dilute so that we can get 2 molar solution. So we need to calculate how many milliliter to take in the stock solution to dilute to 100 milliliter. So for this, we use the formula which is equal to M1 V1, which is the molarity for the stock solution. V1 is which is the volume of the stock solution we need to pick, equal to M2, that is the molarity of solution that we want to prepare, and V2, that's the volume of solution that we are going to prepare. And in the question, they told us that in your disposition you have only 100 milliliter, which means V2 will be 100 milliliter. Then from this one we can calculate V of stock solution, which is the volume, which is the milliliter of the stock solution that we need to dilute so that we can get 2 molar solution that we want to prepare. By rearranging the terms in the equation, you get the volume of stock solution equal to 2 times 100 dividing with 18.4, which is equal to 10.87 milliliters. So which means we need to pipette out 10.87 milliliter from the stock solution and dilute it to 100 milliliter by using distilled water. But remember, we are having the acid. We cannot, we need to be careful when we are diluting the acid, because we cannot add water immediately to the acid, but you can add the acid to the water. So in that case here, you need to be careful when you are diluting this kind of concentrated sulfuric acid and the other acid solution. And again, remember, we need to be accurate. We are having 10.87, which means we have 10 milliliter. We can measure 10 milliliter by using a pipette. But for measuring 0.87 milliliter, it becomes difficult. That's when we need a micropipette. A micropipette will help you to measure 0.87 milliliter. So which means you will set a micropipette in 870 microliter. Then it will be easy for you to pipette out 870 milliliter of the as the 870 microliter as added to 10 milliliter, so that you will get 10.87 milliliter. So what you have to do, you will fill the flask about halfway or more with distilled water. So you need to fill the flask halfway with distilled water. Then you will add 10.87 milliliter of the acid, and then you will bring up to volume with more distilled water. So that is what I was telling you. To measure accurately 10.87 milliliter, you will add 10 ml of sulfuric acid, and then you will use a micropipette to add 870 acid. (175 milliliter of 1.6 molar aqueous solution of lithium chloride is diluted with water to a final volume of 1 liter. What is the final concentration of diluted solution? So here also we need to use the formula, and then we calculate the M2, which is the concentration of diluted solution. Then we will get 0.28 molar solution. Let's see number K. In order to generate a calibration curve, which is the last, for iron, a student needs to prepare different solution containing iron with known concentration. The student has a standard solution of 400 milligram per liter of iron in the stock. Explain how will he prepare 0.2, 0.4, 0.8 and 1 milligram per liter of iron standards from 100 milligram. The student has only 100 milliliter flask in the laboratory. So it's the same, but the formula, we need to calculate how many milliliter to take in the stock solution to dilute to 100, because the student is having only flask of 100 milliliter. For 1 milligram per liter of iron, he will need 1 milliliter. For 0.8 milligram per liter of iron, you need 100 microliter, which is 0.8 milliliter that you have compared to microliter. So by multiplying 1,000, we get 800 microliter. For 0.4 milligram per liter iron, you will get 100 microliter, and for 0.2 milligram per liter, you get 200 microliter. Of course, because he is having microliter, the student will need a micro pipette. He will fill a flask about halfway with distilled water so that he can add acid. So we are allowed to add acid in water, but not the inverse. It's not allowed to add water in acid, but it's possible to add acid in water. So that's why when you are diluting acid, I told you that you need to be careful. And then you will replace a small quantity of iron of stock solution in small beaker, because you need a small quantity. You will not pipette in the stock solution. You take stock solution, and you will have to place a small quantity of iron stock solution in small beaker. Then you will use micro pipette to pipette out the required volume from the beaker, the calculated volume above. But remember also, you have filled the flask that you want to prepare your standard halfway. The flask are filled halfway. Then you will add 200 microliter of iron in the first flask, add the 400 microliter in the second flask, add 800 microliter in the third flask, and then in the last you will add 1 milliliter of iron stock solution in the fourth flask, and then you will dilute and fill the flask up to the mark. So it's also possible to prepare in between. You can prepare a solution of 0.4 from a solution of 0.8, or it's possible also to prepare a solution of 0.2 milligram per liter from a solution of 0.4 milligram per liter by diluting twice the solution. For example, if you can take 10 milliliter of 0.8 milligram per liter and dilute it to 20, in that case we have 0.4 milligram per liter. Same as when you take a solution of 0.4 milligram per liter and then you take 10 ml solution of it, or take 5 ml solution of it. If you take 5 ml solution from 0.4 milligram per liter and then you dilute to 10, so you get 0.2 milligram per liter. Same as if you are taking 10 ml of 0.4 milligram per liter solution of iron, and then you dilute to 20 milligram to 20 milliliter. In that case, you will be having 0.2 milligram per liter. So that's dilution twice. So when you dilute twice, you take 5, dilute to 10, you take 10 diluting to 20, you take 20 diluting to 40. So that is diluting twice. In between, then you have one solution, you can prepare another solution from one solution. That's the end of my presentation today. I hope that we'll see next time. So that was around a lecture of 37 minutes, around 38 minutes. That was a very long lecture. Hope that next time we get also the extra lecture in the same hours, Sunday this time. Thank you very much.